Okay, girls, I just want to go through some key terms that's a little bit of an extension from last year. We did speak about some of these, but I actually this year want you to write these down and to gain an understanding of them. So here is just to begin, a standard model of performance. Now, you don't really need to take a screenshot of this, but I just wanted to explain a couple of things. So performance and quality of performance depends on these three facets. So your VO2 max, which we'll talk about later in this lecture, and you'll also test this at UQ in a couple of weeks' time. Your economy, so how efficient you are in sort of saving energy. Best way to explain that is to think about those runners that swing their arms across their body. That's exerting a lot of unwanted and wasted energy. And your lactate threshold. Now they say that out of these three, this is the one that you can really train and improve. And last year you would have spoken a lot about in your essay that you needed to increase your lactate threshold. But I wanted this year explain that in a little bit more detail so that you can apply it to this assessment task. Okay, so what is lactate threshold? It's the point at which energy for exercise can no longer be sourced aerobically, and therefore, as a result, lactic acid begins to accumulate anaerobically. Okay, so it's all about how fit you are aerobically, and the point at which energy for exercise can no longer be sourced by that energy system, and therefore you turn to your anaerobic system. And we know the byproduct of the anaerobic system is lactic acid buildup. So there's two types of lactic threshold 1 and 2. So lactic threshold 1 refers to the exercise intensity at which lactate or lactic acid starts to accumulate in the bloodstream faster than the body can remove it. And we know when that lactic acid sort of starts to hit us, the severe outcomes is where you just cannot run or move anymore. And yet you collapse like that runner at the Commonwealth Games. To develop your aerobic system, you are targeting a sub-max heart rate of 75%. So that's why I said in the previous lecture, it's really, really important that you need to have good aerobic fitness so you can increase your lactate threshold. By increasing lactate threshold 1, the body can develop a tolerance to depleting creatine phosphate during muscle contraction, so that the body can withstand depletion longer. Okay, so high lactate threshold. Okay, so we want to sort of delay that lactic acid buildup, and to do that, we want to try and utilize our aerobic system. So the fitter we are, the more longer we can use our aerobic system and not have to draw on the anaerobic system. And we know the byproduct of anaerobic is a lactic acid buildup. Lactic threshold 2, so all about anaerobic, is defined as the upper limit of lactic production and clearance used to develop the anaerobic capacity, which in turn develops one's speed. It's aimed at high intensity, so 85% to 100 sub-max heart rate. By increasing your lactic threshold 2, lactic acid limits will increase due to the buildup of your lactic acid in the muscles. Therefore, a tolerance to these limits will develop. So you've got a high lactate threshold. So basically, you're training, you're incorporating into training intensities, utilizing speed work or something like that, but you're aiming for that 85% max heart rate continuously throughout your training, so you develop a higher lactate threshold. So your lactic limits will increase because you're used to it. Your body is used to that lactic acid buildup. Therefore, there's more of a tolerance and you can keep going. So that's called developing a high lactate threshold. Aerobic fitness. A higher level of aerobic fitness will not only allow a higher rate of energy production, but recovery after exercise will be improved. So it's all about the intake of oxygen in your body. And we know the fitter you are, the more oxygen you can get inside your body, and it can enable you to recover faster. Important for sports where there are high levels of effort broken up by rests, such as touch. So when you're going for a sub or when the play's down the other end, you need to be able to get oxygen into you quickly in order to recover and ready to go again at high intensities. Aerobic capacity is dependent on your muscular endurance fitness. Okay, so you've got to have your muscles need to keep your muscles need to be able to keep going in order to also work on your aerobic capacity. VO2 max, so like I said, you'll be testing something similar like this at UQ in 2 weeks' time. So VO2 max is the maximal amount of oxygen that the body can consume. It dictates your aerobic fitness. And like I said earlier, the greater oxygen consumption, so the greater amount of oxygen you can consume, indicates a greater ability to produce energy aerobically. So greater aerobic capacity allows the body to perform to a high level before the energy turns to the anaerobic process. And as we know, that equals lactic acid buildup. Anaerobic capacity, it's the ability to produce energy in the absence of oxygen. It occurs when there is not adequate oxygen being supplied to the muscles and the food sources cannot be broken down fast enough to meet the energy requirements of the activity. You know, for example, a 50-meter sprint in the freestyle. So overall, by increasing these two lactic thresholds, so 1 and 2, the body is able to work at an increased intensity for a longer period of time. It enhances fatigue, resistance, etc. An athlete that trains compared to an athlete that doesn't will have better anaerobic threshold, better lactate threshold, and will perform better. Okay, so if you are training your anaerobic system and you're developing a high lactate threshold, your body can withstand that lactic acid buildup better than others. Both thresholds relate to speed and developing speed. So if you can work on your speed in your training program, you're obviously going to enable a higher resistance to lactic acid buildup as long as you're hitting the right intensity, which is 85 to 100%. So designing anaerobic training programs. So an anaerobic training program involves work periods at very high intensities and has longer rest periods built into the training to ensure that muscles recover and you replenish the ATP before your next rep or set. This applies to all forms of anaerobic training, so things like weight, resistance training. You'll have a rest period between your sets. Rest periods are vital. As we know, you've got to replenish that ATP. Allows for greater intensities to occur if you're resting to replenish. And this is important because the greater the volume of work done at a higher intensity, the greater the physiological adaptations will be. So if you are working at high intensities and working harder, then you can physiologically improve. And that might be things like developing a higher lactate threshold. Anaerobic training will have work periods that are at an intensity above the lactate threshold. So you're working above where that lactic kicks in, okay, and your body really feels it. So you're pushing yourself to break that barrier and to make your lactic threshold much higher, okay? So the onset of lactic acid buildup in your muscles, ensuring that adaptations can occur in the anaerobic system. Aerobic programs, to finish off, the workload should increase as adaptations occur, and training should be specific to the sport. So you're not just running 3K for 6 weeks, you need to be increasing the workload. For aerobic programs, fit, frequency, intensity, time and type must be used to ensure there are physiological adaptations. So you need to be making sure that you're hitting the right frequency, so 3 sessions a week, the right intensity, so around that 70% mark. Endurance training should be done frequently, 3 times a week, and it should be at least above 20 minutes. And here's some examples. Some homework. This is quite important because it explains these terms in a little bit more specific detail, especially lactic threshold and the physiological adaptations that training has on the body, which is important for your assessment task. So it's a different textbook. It's chapter 5 and it's on the OneNote. Thank you, girls.